All right, let's take a look at question number 2. So it says a particle moves along the straight line for 0 less than or equal to t less than or equal to 5. The velocity of the particle is given by the velocity function, negative 2 plus t squared plus 3t raised to the 6 over 5 minus t to the third, and the position of the particle is given by s of t. It is known that s of 0 is equal to 10. Alright, so for part A, we are to find all the values of t on the interval 2 to 4 for which the speed of the particle is 2. So what is the relationship between speed and velocity? Well, the speed is basically the absolute value of your velocity function. Okay, so velocity is a vector quantity because it has magnitude and direction. Speed is a scalar quantity. It has just magnitude. This direction is of no consequence. All right. So there's no such thing as a negative speed, but you can have a negative velocity. All right. So in order to solve this problem, what we just have to do is we're just going to graph the absolute value of the velocity and see when it's equal to 2. Okay. So to find when the speed is equal to 2, we're going to solve the equation absolute value of v of t, which is equal to speed, equals 2. Okay? So our velocity function is pretty complicated. So what we're going to be looking at is the solution to the equation absolute value of negative 2 plus t squared plus 3t raised to the 6 over 5 minus t to the third equals 2. Okay, so this is not that easy to solve, so we're going to employ the use of our calculators in solving this equation. All right, for t. So let's use the TI-89 titanium first. Now an easy way to do this is to graph both functions. So the first function is absolute value. You go to catalog ABS is absolute value and enter the function carefully. Negative 2 plus remember the independent variable here is x, not t, so we're going to have to use x to the second power plus 3x, the entire quantity raised to parenthesis 6 over 5 minus x to the third. Close the absolute value parenthesis, enter. All right, let's check to make sure that our entry is correct. Negative 2 plus x squared plus 3x to the 6 over 5 minus x to the third. Excellent. Now we want to graph a second line, which is 2, enter. Now we're going to look for the intersection of these two functions. So let's go ahead and graph it. I'm on F3, we'll graph the functions for us. Alright, that's the absolute value function. And then we have the horizontal function, should be coming very soon. And there you have it. Okay, so we're looking for the point where this absolute value, the absolute value of the velocity, which is speed, is equal to positive 2 between 2 and 4. Okay, so we have to be really careful with our domain here. We're just looking at 2 and 4. So I'm going to use the Windows zoom menu to basically zoom in on this intersection region right here. So F2, zoom box, enter. How about we pick, this is 1, 2. Let's move it to the right and then go up a little bit. I just want to focus mainly on this intersection area right here. Just move it to the right a little bit more. And press enter. And then now I'm going to go all the way to the right of the two intersections. And then scroll down. So all I'm just going to get is a snapshot of this region right here. Okay, let's graph it. Press enter. So there goes your, see, that's your function. And then the absolute value function, and then that's the other function right there, the y equals 2 function. Now, what we're going to do is look for the intersection. The two intersections right here will be the solutions. All right, so let me show you something real quick. If we trace 2, enter, 2 is right here, and then this is 2 and this is 4. So these are the two t values you're looking for. So let's go ahead and look for the intersections. We're going to use F5, option 5, first curve, enter, second curve, enter. Lower bound, we can use, let's see, lower bound, we can use 3, enter. All right, that's good. And then upper bound, we have to do this manually. Go to the right of that first intersection and press enter. And then 3.127 is our first solution. 3.128 to 2 decimal places. So the first one is t equals 3.128. Okay, but we still have another intersection. Let's look for that. We're going to go F5 again. We're looking for the intersection, option 5, first curve, enter, second curve, enter, lower bound, enter, upper bound, we go to the right of the intersection, enter, we'll get 3.473. Okay, so t equals 3.124 and t equals 3.473 are the times where the speed is equal to 2. All right. Okay, let's move on to option B. It's the write the expression involving an integral that gives position s of t. Use this expression to find the position of the particle at t equals 5. All right, so we're given the velocity function and we have to find the position. Okay, so for part B, you do not want to forget that we're given an initial condition that s of 0 is equal to 10. All right, so what's the relationship between position and velocity? So remember our splash continuum. If you differentiate velocity, you get, if you differentiate position, you get velocity. If you integrate velocity, you get position. So for part B, our position function s of t will be the initial distance when t is equal to 0, which is 10, plus the integral from 0 to any arbitrary t of the velocity function. We have to change, the variables have to be different. So of the velocity function, v of x dx. Okay, so that's the setup. Now we're asked to use it to find the expression for the particle's position at t equals 5. So we're basically looking for s of 5. So s of 5 equals the original position plus the integral from 0 to 5 of our velocity function, which is -2 plus t squared plus 3t raised to the 6 over 5 minus t to the third dt. Okay, so let's go ahead and calculate what this is. Just simply plug it into our calculator. This is a definite integral or numerical integral right here. So let's go ahead and figure that out. So we're going to have, let's see, go to the home screen for that. The integral from of 10 plus, actually we start with 10 plus the integral of -2 plus the quantity t to the second power plus 3t, all of that raised to the 6 over 5 minus t to the third. Our variable of integration is t, lower bound is 0, upper bound is 5. Enter. Again, -2.073. Okay, so that's the particle's position at t equals 5. So it's going to be, let's write this down. It's going to be 9.207. So if you wanted to enter this, I did this using a TI-89. If you wanted to enter it using a TI-83, all you simply do is use a numerical integral. Okay, so let's go to the home screen. Let's quit that. Clear that. So simply you go to catalog, second function 0. F equal to F, function integral, enter, and then you enter the function just as we did here, and then comma x, comma 0, comma 5. So it's basically the velocity function, and then the variable, and then the lower limit, and then the upper limits from 0 to 5. And then that will give you what the answer is. So you just basically enter the function there, and it should give you the same answer. Okay? All right. All right, let's look at the C part. The C part says find all times t in the interval 0 to 5 at which the particle changes direction. Justify your answer. So when does a particle change direction? So if a particle is moving, let's say, to the right or to the left, in order for it to change direction, it must come to rest first. Okay? So the particle changes direction when v, the velocity, changes from positive to negative, or from negative to positive. Okay? So it must attain a value of 0 first before this sign change actually happens. So what we're going to do is we're going to graph the velocity function and look for where it changes from positive to negative or negative to positive, or basically a sign change on the domain 0 to 5. Okay? So graph v of t and find where sign change occur. Okay? Where sign change happens. Okay, so let's go ahead and graph it in our calculators real quick. So we have the velocity function is negative 2 plus, remember this is x to the second power plus 3x raised to the 6 over 5 minus x to the third. Enter. Now let's verify that our entry is correct. So we have negative 2 plus x squared plus 3x raised to the 6 over 5 minus x to the third. Excellent. Now let's go ahead and graph it. Now, if your graph window was stuck in the other view that you had before, you can always reset your graphing window. In order to reset your graphing window, you're going to zoom standard. You're going to go back to your standard zoom. So if you press F2, okay, let's wait for it to finish. F2, zoom number 6 is a standard zoom. So F2, 6 will recalibrate our axis into the default or original or standard format. Okay? So this enables us to get a view of the entire domain. We're going from 0 to 5, so these are the two intersections that we're looking for. All right? So we're looking for when v of t equals 0, and there's an actual sign change. So these are zeros right here, so let's go ahead and look for them. The first one, F5, 0 is menu item 2. Lower bound, enter. Upper bound, we can use 1. Since it's to the right of this 0, enter. In the first sign change happens at t equals 0.536033. So at t equals 0.536033, what happens? The velocity changes from negative to positive. V of t changes from negative to positive. Okay, we still have another sign change in our domain. This is where it changes, the velocity function changes from positive to negative. Let's go ahead and look for that. F5 intersection again. uh, wait a minute, it's not intersection, we're looking for the 0, FR2, lower bound, 1, 2, 3, we can use 3, enter, upper bound, we can use 4, enter, and our second sign change happens at 3.31776, so t equals 3.31776. It's a change in direction because v of t changes from positive to negative. Okay, changes from positive to negative. All right. In this case, when it goes from negative to positive, you have a minimum. Okay, a minimum there because you're going down and then increasing. And then when it changes from positive to negative, you have a maximum there. The question didn't ask you for it. I'm just a side note. Okay. All right. So since this sign change happens at these two intervals, what can we say? What can we conclude? Then, therefore, the particle changes direction. The particle changes direction at t equals 0.536 and t equals 3.318. Okay, because there was a sign change in the velocity at around those two times. All right, let's look at the last part. It says, is the speed of the particle increasing or decreasing at t equals 4? We have the velocity function. So if the velocity and acceleration are pointing in the same direction, then the speed is basically going to be increasing at that point in time. All right. So at t equals 4, the question is, do we have velocity and acceleration pointing in the same direction? Okay. So how do we answer that question? We have to find v of t and v of 4 and a of 4 and see if their signs agree or disagree. Okay, so if a of t and v of t have the same sign, then the particle is speeding up in that direction. The particle is speeding up at that t value. Okay, so all we're doing here is just comparing v of 4 and t of 4. So let's look for v of 4 first. V of 4 is what you get when you plug in 4 into the original function. So this is the velocity function. How can we find out what v of 4 is? We can simply do that by tracing it. Let's use a trace. So since this is the graph, we can just press F3. So whenever you press F3, you can enter in any value for your x. So we want to evaluate the velocity at t equals 4. Press 4, enter, negative 11.4758. Okay, so this is the velocity at t equals 4 is negative 11.4758. All I care about is the sign. So this is less than 0 or is negative. Okay, now if the acceleration is positive, that means the particle is slowing down, going in the reverse or downward direction. And if it's positive, if it's negative, the same sign as this, that means it's speeding up. Okay, so next thing we need to find now is the acceleration at t equals 4. So what's the relationship between acceleration and velocity? If you differentiate velocity, you get acceleration. Okay, so a of 4 is simply v prime of 4. So how do we find v prime of 4? Alright, so you can do the numerical derivative. That's easy, but I can show you. Let me show you a shortcut that you can use. Since we already have the velocity function graphed, we can calculate the velocity, its derivative at any x value. Alright, so to do that, we just press F5, and then you see the derivatives menu here, menu 6, dy dx, enter. So it'll ask you where do you want to calculate the derivative at. So you just type in 4, enter the derivative at x equals 4 negative 22.2957. So negative 22.2957. This is also less than 0, is negative. Okay, so this shows that acceleration and velocity are working together. So that means that the particle is going to be speeding at that point in time. Okay, so since the velocity and acceleration have the same sign, and acceleration have the same sign, the particle is speeding out. Okay, the particle is speeding out. All right, so that's that.